we're going to spend some time exploring your vision for what an exciting future might look like, which I guess makes the first question a little ironic. Why are you boring?
Yeah, I ask myself that frequently. We're trying to dig a hole under LA, and this is to create the beginning of what will hopefully be a 3D network of tunnels to alleviate congestion. So, I mean, right now, I think one of the most soul-destroying things is traffic. It affects people in every part of the world. It takes away so much of your life, and it's horrible. It's particularly horrible in LA.
I think you've brought with you the first visualization that's been shown of this. Can I show this?
Yeah, absolutely. So this is the first time, we've just to sort of show what we're talking about. So there are a couple of key things that are important in having a 3D tunnel network. First of all, you have to be able to integrate the entrance and exit of the tunnel seamlessly into the fabric of the city. So by having an elevator, sort of a car skate that's on an elevator, you can integrate the entrance and exits to the tunnel network just by using 2 parking spaces. And then the car gets on a skate. There's no speed limit here, so we're designing this to be able to operate at 200 kilometers an hour, about 200 kilometers an hour, or about 130 miles per hour. So you should be able to get from, say, Westwood to LAX in 6 minutes, 5-6 minutes.
So possibly initially done as like on a sort of toll road type basis.
Yeah.
Which I guess alleviates some traffic from the surface streets as well.
So I don't know if people noticed it in the video, but there's no real limit to how many levels of tunnel you can have. So you can go much further deep than you can go up. The deepest mines are much deeper than the tallest buildings are tall. So you can alleviate any arbitrary level of urban congestion with the 3D tunnel network. This is a very important point. So a key rebuttal to the tunnels is that if you add one layer of tunnels, then that will simply alleviate congestion. It'll get used up, and then you'll be back where you started, back with congestion. But you can go to any arbitrary number of tunnels, any number of levels.
But people assume traditionally it's incredibly expensive to dig, and that would block this idea.
Yeah. Well, they're right. To give you an example, the LA subway extension, which is, I think it's a 2.5-mile extension that was just completed for $2 billion. So it's roughly $1 billion a mile to do the subway extension in LA. And this is not the highest utility subway in the world. It's quite difficult to dig tunnels normally. I think we need to have at least a 10-fold improvement in the cost per mile of tunneling.
And how could you achieve that?
I guess, actually, if you just do 2 things, you can get to approximately an order of magnitude improvement, and I think you can go beyond that. So the first thing to do is to cut the tunnel diameter by a factor of 2 or more. So a single road lane tunnel would, according to regulations, has to be 26 feet, maybe 28 feet in diameter to allow for crashes and emergency vehicles and sufficient ventilation for combustion engine cars. But if you shrink that diameter to what we're attempting, which is 12 feet, which is plenty to get an electric skate through, you drop the diameter by a factor of 2 and the cross-sectional area by a factor of 4. So, and the tunneling cost scales with the cross-sectional area. So that's roughly a half order of magnitude improvement right there. Then tunneling machines currently tunnel for half the time, then they stop, and then the rest of the time is putting in reinforcements for the tunnel wall. So if you design the machine instead to do continuous tunneling and reinforcing, that'll give you a factor of 2 improvement. Combine that and it's a factor of 8. Also, these machines are far from being at their power or thermal limit. So you can jack up the power to the machine substantially. I think you can get at least a factor of 2, maybe a factor of 4 or 5 improvement on top of that. So I think there's a fairly straightforward series of steps to get somewhere in excess of an order of magnitude improvement in the cost per mile. our target actually is we've got a pet snail called Gary. This is from Gary the snail from South Park. I mean, sorry, SpongeBob SquarePants. So Gary is capable currently he's capable of going 14 times faster than a tunnel boring machine. Okay.
You want to beat Gary?
We want to beat Gary. Yeah. He's not a patient little fellow, and we want that will be victory. Victory is beating the snail.
But a lot of people dreaming about future cities, they imagine that actually the solution is sort of flying cars, drones, etc. You go above ground. Why isn't that a better solution? You save all that tunneling cost.
Right. I'm in favor of flying things. Obviously, I do rockets, so I like things that fly. This is not some inherent bias against flying things, but there is a challenge with flying cars in that they'll be quite noisy. The wind force generated will be very high. Let's just say that if something's flying over your head, if there are a whole bunch of flying cars going all over the place, that is not an anxiety-reducing situation. You don't think to yourself, well, I feel better about today. You're thinking, like, did they service their hubcap? Or is it going to come off and guillotine me as they're flying past?
And so you've got this vision then, future cities with these rich 3D networks of tunnels underneath. Is there a tie-in here with Hyperloop? Could you apply these tunnels to use for this Hyperloop idea you released a few years ago?
Yeah, so we've been sort of puttering around with the Hyperloop stuff for a while. We built a Hyperloop test track adjacent to SpaceX just for a student competition to encourage innovative ideas in transport. It actually ends up being the biggest vacuum chamber in the world after the Large Hadron Collider by volume. It was sort of quite fun to do that, but it was kind of a hobby thing. And then we think we might. So we developed a little pusher car to push the student pods, but we're going to try seeing how fast we can make the pusher go if it's not pushing something. Huh. So, I mean, like, sort of cautiously optimistic we'll be able to be faster than the world's fastest bullet train, even in a 0.8-mile stretch.
Whoa. Good brakes.
Yeah. I mean, it's either going to smash into tiny pieces or.
But you can picture then a Hyperloop in a tunnel,
yes,
running quite long distances.
Exactly. So in looking at tunneling technology, it turns out that in order to make a tunnel, you have to, in order to seal against the water table, you've got to typically design a tunnel wall to be a good to about 5 or 6 atmospheres. So to go to vacuum is only 1 atmosphere, or near vacuum. So actually, it sort of turns out that automatically, if you build a tunnel that is good enough to resist the water table, it is automatically capable of holding vacuum.
Huh.
So, yeah.
And so you can actually picture this, like what kind of length tunnel is in Elon's future to running Hyperloop?
Yeah, I think there's no real length limit. You could dig as much as you want. I think if you were to do something like a DC to New York Hyperloop, I think you'd probably want to go underground the entire way because it's a high density area. You're going under a lot of buildings and houses, and if you go deep enough, you cannot detect the tunnel. Sometimes people think, well, it's going to be pretty annoying to have a tunnel dug under my house. Like, if that tunnel is dug more than about 3 or 4 tunnel diameters beneath your house, you will not be able to detect it being dug at all. In fact, like if you're able to detect the tunnel being dug, whatever device you're using, you can get a lot of money for that device from the Israeli military, who's trying to detect tunnels from Hamas, and from the U.S. Customs and Border Patrol that try to detect drug tunnels. So the reality is that Earth is incredibly good at absorbing vibrations, and once the tunnel depth is below a certain level, it is undetectable. Maybe if you have a very sensitive seismic instrument, you might be able to detect it.
So you've started a new company to do this called The Boring Company. Very nice, very funny. But
What's funny about that?
How much of your time is this?
It's maybe 2 or 3%.
You've called it a hobby. This is what an Elon Musk hobby looks like.
I mean, it really is. Like, we actually, this is basically interns and people doing it part-time. So this is, we bought, some second-hand machinery, and it's kind of puttering along, but it's making good progress.